So you've heard me talking throughout these videos about absolute convergence. And I've given some descriptions of it, which have probably been confusing and I know have definitely been rushed. Uh, and I've mentioned that there are different kinds of convergence. Well, this is where we can start talking a little bit more about that. So first, just kind of some definitions. When I'm talking about absolute convergence, what we're doing is instead of seeing if our original series converges, we look at the series of the absolute values of each term being added. If the series of absolute value terms converges, our original series must converge too. It's a very, very powerful thing for us. And it simplifies things a lot for us because then we don't have to worry about negatives and all of that. It's great. If a series converges absolutely, there is no need to talk about any other type of convergence, specifically this conditional convergence. The conditional convergence is what if the series of absolute values diverged? Just because the series of absolute values diverges doesn't necessarily mean that the original series diverges. This is particularly true when we're looking at alternating series and when we're looking at endpoints of our intervals of convergence. So if the absolute convergence doesn't work and I have negative terms, I have to check for conditional convergence. If I didn't have negative terms to begin with, I didn't actually check for absolute convergence. Or convergence is the same. So I know that's confusing. It makes sense once we look at some examples here. So if we look at the series 1 as n goes from 1 to infinity of -1 to the n plus 1 times 1 over n, and I'm just asked, does this converge absolutely, conditionally, or does it diverge? So I first check absolutely. So we'll always check absolutely first. Absolutely means that I'm looking at the series, n goes from 1 to infinity, up to the absolute value of -1 to the n plus 1 times 1 over n. Well, that's this. The absolute value gets rid of my -1 to the power part. So this is really the series, as n goes from 1 to infinity, of 1 over n. This is a p series because I have a constant on top, n to a power on the bottom. So the p is equal, to 1, and 1 is not bigger than 1, so that diverges. This does not mean my original series diverges. It just means the absolute value of the terms diverges. The series of the absolute values of the terms diverges. So next, I have to check conditionally, which means I just want to look at the series, -1 to the n plus 1 times 1 over n. I notice this is an alternating series. The non-alternating part is always positive. The non-alternating part, as n gets bigger, is decreasing. And the limit, as n approaches infinity, of the non-alternating part is 0. So this converges conditionally by the alternating series test. So I can say it's conditional because I already said it does not converge absolutely. So if I'm being asked, does it converge absolutely, conditionally, or diverge, check absolute first, because if it converges absolutely, you don't have to check anything else. If it diverges absolutely, I check the conditional. And if that had diverged, my series diverges. So if you're asked, is it absolute, conditional, or diverge, always check absolute first, because if it converges, you're good. Don't have to do anything else. If the absolute does not converge, check conditional. And then if that doesn't converge, your series diverges.